Okay, so we've got a question here for the numbers n in the set of natural numbers. So that's the numbers 1, 2, 3, 4 and so on. That's the whole numbers. We need to show that n squared plus 2 is not divisible by 4. So how do we go about that? Well, one way is we could use modulo arithmetic. So modulo arithmetic, we'd use mod 4. So modulus 4, as if we got this 4 here. So if we draw up all the possibilities for all the numbers mod 4, we have 0, 1, 2 and 3. Because 4 mod 4 is 0. And we know that 0 is not in the natural numbers, but this is for the modulus. So here we've got the modulus. Okay, so now we need to do n squared. So using modulus arithmetic, n squared, 0 squared is still 0, 1 squared is 1, 2 squared is 4, so that's now back to 0, and 3 squared is 9, 9 in modulus 4 is 1. So now we're going to do n squared plus 2, because that's what we originally asked for. Just add 2 to all these numbers and we get 2, 3, 2 and 3. Now what we can see is that modulus arithmetic with modulus 4, none of these numbers will be divisible by 4. So therefore with this bottom line here, and we can just write by mod 4, n squared plus 2 is not divisible by 4. That's what this symbol means here. Okay, next method we could use is logic. So now we're going to use logic. Let's write logic. So that's the next one. We just box this one off. That's finished. So modulus 4. So now let's look at the possibilities for n. So if n is an even number, we then end up with, so let's put right down here. So if n is even, then that leads us to n squared is also even, and an even number squared will be divisible by 4. So this is now divisible by 4. But by adding 2, we now lose this property. By adding 2 is not divisible by 4. So that's the even numbers out. Now what about if n is odd? So let's write n equals an odd number. So odd number squared. So now n squared would now be, an odd number squared would be another odd number. So that leads us to an odd number. An odd number is not divisible by 4. So let's just write that down by there. So therefore this is not even. And then by adding 2, we still get an odd number. So by adding 2, we still get an odd number, and all odd numbers are not divisible by 4. So that's symbol again, not divisible by and divisible by. Okay, that's the logic method out. What about proof by contradiction? So contradiction. So that's our next method. So by contradiction, we're now going to assume that n squared plus 2 is divisible by 4. So now if we say n squared plus 2 is divisible by 4. So how are we going to go about going on from this proof here? So now what we do, we let n squared plus 2 equal 4k. So n squared plus 2 equals 4k, where k is an integer. So you could have 0, 1, 2 and so on. Even the minus numbers we could have for that. Okay, now let's just have a look what we can do here. Manipulate this with algebra. N squared plus 2 equals 4k. which we now subtract 2 from each side. We get n squared equals 4k plus 2. Now we can factor this out. So now n squared equals 2 times 2k plus 1. Now we know that this is an even number. So this is an even number. So now there is a possibility this could be the correct statement, because whatever k is, multiplying by 2, you still get an even number. So now we take the square root of both sides. So if we take the square root, and take the square root of this, we then end up with n equals square root of 2 multiplied by square root of 2k plus 1. Okay, now 2k plus 1, if z is an integer, this is going to be an odd. So we know here 2k plus 1 is odd. And the square root of an odd number is going to give us an odd number. So for example, if 2k plus 1, if k is 4, we end up with the square root of 9, which would then give us 3. So that's an odd number. That doesn't break our proof just yet. But then the problem is here is square root of 2. So square root of 2 is an irrational number. So this is like 1.41 and goes on and on and on. So whatever you multiply this number by an odd number, this will not be divisible by 4. So hence the statement is wrong. So n squared plus 2 is not divisible by 4. And there's 3 good methods there to show that this function here is not divisible by 4. Okay, so we've got a question here for x is in the set of real numbers, so that's anywhere on the number line. The modulus of 3x minus 28 is greater than or equal to x minus 9. And what we want to know is this statement never, always, or sometimes true? So first of all, I'm going to do some algebra on this one. So as it's modulus, we're going to have to split this up into 2 different equations. So the first one, 3x minus 28 is greater than or equal to x minus 9. Okay, now let's bring the x across. So modulus of 3x minus 28 minus x is greater than or equal to minus 9. So now 3x minus the x, we got 2x. It's greater than or equal to, then add 28 on both sides, minus 9 plus 28 will give us 19. And then for the other one, we'll go 28 minus 3x, so that's the reverse of that, is greater than or equal to x minus 9. Okay, so this time we're going to bring the minus 9 across. So now we've got 28 minus 3x plus 9, because if we add 9 to both sides, that's greater than or equal to x. Okay, so now 28 plus 9, 37. And then we add 4x to both sides to get rid of this one. That's greater than or equal to 4x. So therefore, x is less than or equal to 37 over 4. Same for this one here, x is greater than or equal to 19 over 2. Okay, so that's our solutions for this inequality. Okay, so what we want to know is now is when does this side and this side equal 0? Well, x minus 9 equals 0, that's pretty straightforward. That leads us to x equals 9. So that's when this one crosses the x-axis. What about this one? So 3x minus 28 equals 0. That leads us to 3x equals 28. X equals 28 over 3. So it's just over 9. So therefore we can draw the graph of both of these functions. Hopefully we're going to prove this. So that's our x-axis, that's our y-axis. Now we're interested in the points near 9. So let's just write 9 here and 10 here. Now we know this is not to scale, because that's definitely not going to be the right gap, but this is the bit that we're interested in. So x minus 9 crosses the axis at x equals 9, and it will hit y at minus 9. So this is going to go something like this. That's our x minus 9. Now the modulus one, that's going to be like a zigzag. Now we know that crosses the axis at 28 over 3, which is 9 1/3. So this point here is 28 over 3. Now what we'll have with that one is, this will go up here like this, and up here like this. So we're going to see that this inequality is true. If I just bring this line up here a little bit more, this inequality is true for these points here and for these points in here. So therefore we can say that this inequality is sometimes true, because it's not true in these parts, it's not true here, it's not true here, and it's not true down here or here or here or all the way around here. So this inequality is sometimes true.